Well, greetings students, good to be back with you again. We're going to continue on our drill tap bore project that we started. This will be considered session number 2, which we will create our thread mill, which is a little bit involved, and then we'll begin to machine this part. So without any further ado, we're going to go up here, you bring up your file here, and make sure that you have all of your tools created up to and including the 1/2 inch. So if we go in here to the tool file here, we see we have tool number 1 is the 2-inch face mill, tool number 2 the 3-inch number 3 center, tool number 3 letter F, tool number 4 5/16 18 tap, and then we had a 1/2 inch flat end mill. So now we want to go into our tool filter, okay, and say none again. And then you'll notice here that there's thread mill. Now, one thing I have to say about Mastercam, they do a great job of creating all kinds of tools for you. However, when it comes to thread mills, it is considered a special tool, and they want you to create the tool. So even though I click on this and say OK, you'll notice here there's nothing down here. So what I have to do is I have to right click and say create tool. And then you'll see that this tool will come up and it has nothing to do with a thread mill. So it's showing here a 1/2 inch flat end mill. So what I want is a 1/2 inch thread mill. So I'm going to type in okay. And now I have to select thread mill from here. So I come down, drop this down, and pick thread mill. And all of a sudden it shows a thread mill here for me. And it gives me tool number 1. Well, this is going to be tool number 6. So type in tool number 6. You'll have to type it in each time. It's not going to do it by itself like before. Tool number 6. And the helix angle and up, you don't touch anything there at all. The next category is going to be the geometry itself. And so here's where you're going to fill in. It's Unified National. Okay, you'll notice here they have metric, Acme, and so on and so forth. It's Unified National, okay, because we're trying to create a 1" 12 thread, and that's 1" 12 NC. All right. And so we need to put the threads per inch in here, which in this case is going to be 12 threads per inch. And then we do the outside diameter. Outside diameter is going to be 0.500. The overall length they have is 2.5. The cutting length, we need that at 1.75, so we're going to have to change some things here. All right, and then the shoulder length, or after the shoulder length is the shoulder diameter. We want to make this 0.4. If you get a carbide thread mill, usually the shank is about 100,000, sometimes smaller. But then you have some that are right on size. So I'm going to make this 0.5 just to make it right on size, just in case you might have trouble finding something like that. And then they have the shank diameter, which is 0.5. And make sure it says it's straight. And pretty much that's all you need to do for that category. 12 threads per inch, outside diameter 0.5, overall length 2.5, cutting length 1.75, shoulder length 1.75, shoulder diameter 0.5, and shank diameter 0.5. Okay? All right, so then we go to our next and last category, and we're going to be, now this is not a tap, so you don't have to multiply the speed times the pitch. A thread mill works entirely different than a tap. The thread mill actually goes in a circle and it advances in Z, going down, okay? Every time it makes a 360-degree rotation, it will rotate 1 pitch. And that's where you get your spiral thread when you use a thread mill. The thread mill does not have a taper or have threads on a helix like a tap does. These are straight threads. All right, so the feed rate. So let's go back to the speed first. I'm going to say I'm going to make this at 600. And it is going to be carbide. Retract is 50. Plunge rate 18. And our feed rate, it doesn't matter what our feed rate is for this. We don't have to calculate, like I said. So you just put something that makes sense. So I'm going to put 10 inches a minute for that. And it's going to be 4 flute. And I can click up here and make sure that that is changed. And I'm going to say OK. Now you'll see that it shows up down here. And now I need to drag this up and put it in place. So I shouldn't need to go back and change that at all. So at this point, I should be able to hit OK on this and save the changes. Yes. Now if I go into the library again, I should have everything I need here. It's going to remember this for future reference. When you select thread mill again, this will be an option. And as you build options for thread mills, they will give you a list of them that you have created over the time you've been machining things in Mastercam. All right, so we're done with that. So we're ready to start doing some machining operations here. All right, so we need to go to toolpaths here, back to where we were. And you'll notice that there's this what's called toolpath group 1. All right, so that's where we want to be. And we want to extend our programming all the way down here for this part. So I'm going to right click right here. And I'm going to go to Mill Toolpaths. And I'm going to select Face. Because I want a face milling operation. Now, in the face milling category here, we have to make sure that we have C-plane selected and that we have wireframe selected, because that's what this is going to be from a wireframe. And then down here at the bottom, you want to change the 3D to 2D and make sure the C-plane is top, the T-plane is top, and the work center is top. If you don't have those right, it's going to go and do some weird stuff. So I have not selected, what chain I want to use here yet, because actually I don't need to. Because it is, as it says here, select OK to use define stock or select chain 1. So we created our stock here, so we don't need to create a chain for that. So we're just going to say OK down here. Once we change this to C-plane and wireframe, we just hit the green check mark and our technology menu comes up. You'll notice that our tool path type is selected is facing. It remembers that. And then we go into tool. So now we want to go up to face mill and we want to click on face mill, double click on it, and you shouldn't have to double click on it. I take that back. We just want to click on it one time, okay? And then we want to go to holder next. This holder is fine for what we need. We don't need to, if you go to here, it's going to do some weird stuff. So your best bet is to leave it at default. And that'll be fine. Actually, what happens is these come with a pilot here, a 3/4 pilot, and that goes into your tool holder, which in our case is a CAT-40. So you'd have to get a 3/4 CAT-40 tool holder to put this in and clamp it down. All right, the next thing is going to be the cut parameters. And it shows you a picture of how this would look if you use one way. But if I use zigzag, which is what I want, you'll see that it does radial, okay, which is what we want in this case. There are other options here. You can do one way, you can do one pass. If you have a big enough face mill to do the whole part, you could just do that. We are just at 2 inches on the width, so we really don't want to use that. We could go to dynamic, which is going to do whatever it wants to do, okay? So the best selection here is going to be zigzag to cover this whole surface. We want to do this in climb milling to give it the finish. So when this goes in, it's going to be climb milling. So it's going to start over here and come in and go around, come in and go around to continue to do climb milling throughout the whole face milling operation. That is going to give you the best finish. So stick with that. Our tip compensation is going to be tip. We don't want the center of the tool. We want the tip of the tool to be used, okay? Move between the cuts is linear. This is all basically default. Custom roughing angle, check mark, even number of passes. If you don't want an even number of passes, you can uncheck this, but I think it's all fine. As far as the overlap is concerned, it says 25%. So when it comes up here, it's going to overlap and come in here 25%, come down, and so on. The length, as far as the length is concerned, this overlap up here and over here, we're talking 110%, which is 2.2. So it'll just go off the edge, okay, of the piece in each direction here. The approach distance at 50% of the tool diameter, and that's what this means. That this is percent of tool diameter. So the approach distance is 50%, which is 1 inch. So that should get us just at the edge here. And then exit distance is going to be also 50% at 1 inch. So that's all good. Step over distance is 75%, so it's 1.5 between passes. Now, down here, there is one thing that you will always have to change, and that is the stock allowance. We don't want to leave anything on the face. We want to take it to size. Now, if you want to do, let's say, 2 facing operations, then you can leave something on here, and that would be your rough cut. And then you would go back and reface mill it and take it down to 0, which is what I'm going to put in here. We only have 31.2 material on the top of the piece, so we really don't need to take any more than 1 pass. So our distance then, there's no stock to leave at all. We want to take it right down to Z0. There's no depth of cuts. If you want depth of cuts, you have to check this off and then put in a value. If you're taking 1/4 of an inch off of a face, then you're probably going to have to use this. But if you're not taking anything but a 32nd, it's not going to be needed. So you don't need depth of cuts. So I'm going to skip over that. I'm not going to check mark. If I check mark this, I'm going to have to fill in some stuff here. So I'm going to say linking parameters next. This is an important category because you want to make sure that all of this is set to absolute. So right away, before you do anything else, set all these to absolute, and your retract doesn't need to be any more than 0.100. So your feed plane should be 0.100 also, where you begin to feed down and then come across. And the top of the stock in this case is 0.0312. So you make sure you type that in there if it is not already in there. There is going to be no depth of cut because when you take this 32nd off, that is going to be considered the face of the part, which is Z0. So you don't want to put anything on there to make sure this says 0. The next thing you have to do, the only thing that's left to do here is the coolant. Making sure that you say that the coolant says on. And then hit the green check mark, and you should have, and you can see here there's some lines here showing the face milling operation. All right, you can go in here now and you can check this out by just doing our back plot and just check this off, and you'll see the tool coming across and doing the zigzag operation that we saw or that we filled out. All right, now if you're not quite satisfied with that and you want to be sure that you're getting the top of the part, a couple of things you can do. You can hit the front here, and then you can go ahead and back plot it and take a look carefully, zoom in on it, and see if the tool is actually hitting the top of the surface of the wire frame, and it is. But if that's still not satisfactory, you can You can hit green button here. You can make this again into isometric, and then you can go to clicking this right here. But I would probably start by clicking machine group 1, where you're starting at the very beginning, and hit excuse me, verify. And you wait for a second, and it'll put you in verification. And the first thing I'm going to want to do is is to uncheck the holder itself. I don't really need the milling holder here. I just want to see the actual cutter. And then I'm going to make sure that I bring this bar back to slow so that I can actually see what's going to be happening here. Don't want it to be too slow though. Now, if you can see your geometry here, that means you've taken off all 31/2 thousandths of material. If you want to see more precise, you can go to simulation, and again you can bring this bar back here, and you can hit start, and it'll do a little better simulation. Personally, I like a Mastercam simulation a lot better than I do Mastercam, in that you do not have to go to a different page to see the action, and you don't have so many options here. So that all looks good. So to get out of that, we go up here and hit the X and get back to our regular part. And now we're ready for our second operation. The second operation I've chosen here is to do the periphery. I want to make sure the periphery is all done after the face milling operation to bring everything into size. So I'm going to go up here to the right again, and I'm going to right click, and I'm going to call this contour. Now this time I'm going to have to make sure that I do a chaining of this. Now it's important that you are careful with where you pick the first part of the chain. So I'm going to go in here and I'm going to grab it should be giving me the whole thing. All right, let me get out of this. It should be giving me the whole thing. Oh, here's what's wrong down here. You need to have the C-plane at top, and the T-plane at top, and the work center at top. Remember I said about this being, you know, if it changes its approach, your tool will also change that approach, and it won't let you select what you really want here. So now that that's fixed, top, and top, and we're at 2D, we'll go ahead and do this again. Right click, tool pass, and contour. And now it's waiting for me to select. Now it lets me select. Now, what I was saying earlier is you want to select this close to here, because it's going to pick the center of the part side here to loop in and loop back out. So it's going to loop in like this. It's going to go around, come back up here, and loop back out. So if you pick the chain here, close to the lower left-hand corner, it's going to show an arrow going clockwise. And of course, if we're going clockwise, that's going to mean that since we're doing the outside periphery, we're going to actually be climb milling, which is what we want for this. We want a decent finish on the periphery as well as on the surface. Remember, we made sure that that was climb milling as well. So those are two things to think about. If your arrow is going the wrong direction, you have the possibility here of saying reverse. Do you see that? I don't want that, but if it gives it to you in a wrong direction, you can reverse it down here. So now that that's all good, I'm going to go and say OK, and then notice it'll say here contour. Now my tool I'm going to choose for this is going to be the 1/2 inch end mill. So I'm going to grab that, and then I'm going to grab the holder next, and this time I'm going to pick a holder that's a little more conducive to what you would see in a regular 40 cat taper holder. Now, the length here is really long, so I'm going to put in 2 inch here and see if it'll take it. Doesn't always take what you want. Sometimes it says it can only do so much and will give you an error message there. In this case, it let me do this at 2, and that's exactly what I want. Then I do the cut parameters next, and this is going to be cutter comp left, so we want to make sure it says computer here. There is control, where, reverse, where, off. I'm going to make sure we say computer here, that our contour type is 2D, all right? If you're going to do a chamfer, by the way, you would use chamfer if you're going to be doing chamfers, which we'll do in the future, near future. Cutter comp left, we want the tip to be compensated for down here. Now, the question is, do we want any material on the walls of the floors? Well, we're not going to need any material on the floors, because what we're going to do is we're going to go down a little over 1 inch and go around this part, and we will machine off the other side later. So the only thing we need is something on the wall. So I'm going to say 0.01. It'll give you 10 thousandths on the wall, all the way around the periphery, so that you have that much to take off when you do your final skim. Depth of cuts is going to be definitely necessary this time, so you're going to go in here and you're going to put in a maximum rough step of 0.25. And it doesn't have to be that, but that's just so that it gets done the simulation pretty quickly. This part down here is when you want to get down to a floor and you want to have a number of cuts to bring it to the floor. But I don't use this very often, so we're going to bypass that and say keep the tool down, and the depth of cut direction is step down. All right, and then the next thing you want is the lead in and lead out. This is your default, and it's a 100%. So it's going to be basically tangent coming in tangentially or tangentially at 0.5, and the arc is going to be 0.5 arc, and it's going to be, at 90 degrees. The only thing I need to change here is make sure I go in here and hit this double arrow to make sure that everything on the exit is the same as the entrance. Very important. We will not need to fill out any of these at this particular time. We do not need multiple passes. If we had more than 1/4 inch of material around the periphery on this, instead of a 32nd, we would have to do what's called multi-passes, where it will come in and start going around and take a rough cut and keep on going down all the way to the bottom, go back up, take a little bit closer cut and go around several times until it gets down to the bottom of the part, until you do the multi-passes, the number that you want. We will talk about this later. We don't need to talk about this or fill this out now. Nothing in tabs. Linking parameters is next. Very important that we change this to absolute. Again, absolute, absolute, and absolute. Now, the retract is 0.1 as we did before. The feed plane is 0.1. The top of the stock is no longer 0.0312 because we just finished our face milling operation, so this is going to be 0. And our depth of cut is going to be very important right now. You're going to have to put a minus in here first. And you want to go down there 1 inch, 25 thousandths, minus 1.025, which will get it just a little bit past the 1 inch periphery depth of cut. And we don't need to fill anything out here. And the last thing we need to look at is our coolant and make sure it says coolant on. And then we're going to say OK. And now we have our next operation. Again, we can backplot this and see how this is going to go. You see how it ramps in and ramps out in the center there? That's because we chose this when we started to create our chain. And you can look down here at the bottom to see how far it went. So if I do that again, you can see my cuts down here. 205 minus 410 minus 615 right down here at the bottom, minus 820, minus 1 inch 25. So what is happening here is Mastercam is taking a look at the value we gave it. We said that we wanted increments of 250 thousandths. But because we are going around this multiple times more than just the 4 cuts, because we have to go to 2 inch 50, or 1 inch 50, or 1 inch 25 thousandths, it calculates the depths and works them out. So it's like a smart cut. Now, if you want to see this played out in your verification, you can simply do the verify. And again, you can go ahead and machine this out and watch this, cut this. All right, now, if you want to see if there's a shelf down here, you can go to the top view and you can rotate this and you can see that there's a distance here. Well, what is that distance? Well, if I right click and say dynamic rotation and then hold my left key down, you'll see that there is a shelf here and that we still have some material on here to take off, right? So that's leaving that material on there, that 10 thousandths that we want to take off in our final cut. So I'm going to put this back to isometric, if it will let me. And I'm going to get out of there. Hello? I'm going to say fit. And we have that. So that looks good, and we're ready now to do our final cut. Now, one thing you can do, and you can do this in a Mastercam as well, you can actually copy something, an operation that you did, if it's using the same tool, and it's basically the same operation, but you're just doing a final cut. We can go up here and grab the contour here, and we can right click and, well, I'm sorry, and you can click on this, right click and say copy, and then come down here, left click on that, just to momentarily, as you see what I did, I got a shade there that tells you that you're picking that spot. Right click and say paste. So what I actually did is I copied this and put it down here directly below it. So all I need to do here is change just a couple of things to get this to do the final skim. So I'm going to go back up here, make sure that my tool type is still contour. The tool is still the 1/2 inch flat end mill. The holder is the same. The cut parameters is what is going to change now. So I'm going to take this 10 thousandths off and make it 0. And this is all going to be the same up here. Then we go to depth of cuts, and we're not going to want any depth of cuts because we want this final skim to be at the last cut down at the bottom here at 1 inch 025. So we're going to see the 0 here with the slash through it. That tells you that there is no depth of cuts in this. The lead in and lead out is going to be the same. Nothing's going to change there. We're not going to be doing multi-passes or tabs. Our linking parameters, though, is going to be still at 1.025, absolute, absolute, absolute. So basically, we're just going to say OK here. I think that the coolant is probably still active, and it is. I said OK here, and then that should do the final skim at the full depth. And if I look down here, it says Z minus 1.025. All right, so I'm satisfied with that. The next thing we want to do is work on the bores, since we already have our 1/2 inch end mill. Actually, we can't. We have to, there is a way we could do it with the end mill right now by doing, and we'll talk more about this, but there's several possibilities in here to actually machine out these holes and the counterbores. So there is a possibility of drilling a pilot hole down through here and then going in here and doing a contour operation, which is what we're going to do today. And then in the future, we'll show you how to do your spiral milling, where it is helixing in and machining it all the way through. That'll be in a later session. Today, we're going to go ahead and just do the drilling operations and put a pilot hole down through here. So our next operation then is going to be to select our positions here for our drilled and tapped holes. So we're going to have to create some chains. So what I try to do is bring it in as close as I can so that I can really grab these centers. It's important that you hover over the center of these to make sure that you get everything. So at this point, I'm going to go up here and I'm going to right click again here and go to Tool, Mill Tool Pass, and grab Drill. All right, and it's telling me to go ahead and pick these particular holes. So I'm going to just get out of the way of this up here because it's going to stay there until I get done. Try to bring this up as close as you can. And it's asking me now to go around here and grab these holes. So I'm going to grab this and I'm going to wait until I see the green. And if you see a red and a green, just click off of it like this and then go back and grab it again. Try to keep it right in the center. You see the green intersection there? That means it's grabbed it. Green intersection. Green intersection. Green intersection. And I'm just going to keep progressing. And you should do the same. And then I'll come over here to my last set of holes here and grab these in the same kind of progression. Basically, I'm going clockwise here. You notice how long I'm waiting. Then I come to the center of my hole here because I want to drill a hole down through here for a pilot hole. And of course, we're doing all of these because we're going to be using our center drill first. So once I've grabbed all of these, then I need to take a look at this list here. If there's anything funky looking here that doesn't have NA or something, you need to probably redo it. In this case, it looks good to me. I have all of the holes listed here, and I'm going to say OK up here. And so now I'm going to go ahead and fill out my technology page. It's going to be a drilling operation. We're going to be using our number 3 center drill. And it's going to give us a tool holder option here, so I'm going to go ahead and do that. I'm going to try to make this at 1.75. See if it'll let me do it. Hit enter. And it does. And then I'm going to go to cut parameters next. And then there's a category up here called peck drill or drill counterbore. The drill counterbore is the one you want to use for center drilling because you're only going to go down one shot to a depth and that's it. So make sure you choose drill counterbore and you don't have to do anything else here at all. There's no dwell. And then you'll want to go to linking parameters, limits, tool axis control, none of that. We don't need to fill out any of that. And whole segments, nothing there. Linking parameters, though, is very important. So we're going to go in here and our retract is going to be 0.1 again. And it's going to be absolute. Our top of stock is 0. And it is also going to be absolute. And then the depth for this is 0.2. And it's going to be absolute. And should be minus, by the way, 0.2. Again, you have to put that minus in there or it will be cutting air. Everything else stays the same here. You don't need to check anything else. The next thing you need to do is look at make sure the coolant is on, and it is not. And I'm going to say OK. And you'll see your chain appear. and you'll see that it is has caused or has created the drilling operation. So I'm going to go to isometric here, and I'm going to go and I'm going to check this out with my back plot. And this is pretty good. You don't need to go into verify for this unless you see something weird going on, but it looks like it's going to progress just fine. And we are going into the part. And that looks good. So we're going to hit the green check mark. We're good there. Now, since we're going to be doing a drilling operation next, we can't just copy and paste here. Notice that we are also doing the 3 center positions of these bored through holes. So we can't really use this chain for anything else except for the center drilling operation. So we need to create another chain for doing just the drilled and tapped holes. So I'm going to go to the top view again, zoom in on it as best as I can, and I'm going to right click up here and hit drill again. And this time I'm going to pick the same ones, but I'm going to exclude the 3 center holes for the bores. So I'm going to zoom in on this, grab this, and do just the drilled and tapped holes. Again, it's trying to give me a center point up there, and I don't want that. This is very important that you carefully do this, because it can really give you a bad output and you'll have to redo the whole thing. Make sure you wait until you've seen the green center point before you left click on it. Gets a little stubborn from time to time. Your best bet is to zoom in on it as best as you can, so you can get an accurate, accurately find the intersection. All right, so this looks pretty good here. Looks good there. So I'm going to say OK. And again, we have our tool, but this is going to be this time the letter F drill. And the holder, again, we're going to choose a different holder that looks a little better. I'm going to try to make this 2.5, see if it'll give it to me. And see, it says 2.75 to 3 is all I'm allowed here. So I'll just go ahead and give it 2.875. And that'll suffice. And we don't have anything to do with stock in this case. The cut parameters are very important. Here you're going to do a PEC drilling operation, and you can put your PEC value in here. I use 100 all the time. That's the best for it, to not to get too many chips in there. So 100 thousandths PEC is very good. We don't need to do anything with the axes, limits, whole segments, but we do need to do linking parameters. So it's going to remember some of the stuff we did here. It doesn't remember everything, but it does stuff like this, weird things, by putting in 0.0312 again when we had 0 in there before. It doesn't remember everything. So, and here the depth is going to be, as you know, these are a 1/2 inch deep. It says here 5/16 18 by 1/2 inch deep. That's full thread. So we want to go down here a minus 0.850 to make sure we get well past that, so we can go down there a minus 625 to give us a full thread at the base. We have to have somewhere to put the chips, so that's why I make this at 850. All right, and there's no need for the tip comp. Nothing here is necessary here. We're all done. We do want to check to make sure our coolant is on, and it is, and we're going to say OK. So if we put this into isometric, we can now check to make sure that it does what we want it to do. And you can look down here to see how far it goes down. Looks like it's going down the way it should. All right, that looks pretty good. So we're going to accept that. And now we're going to create a chain now, or use the same chain, I should say, for the tapping operation, because that's what we want to do here. So we'll go ahead now and we'll right click here and click on drill again. There isn't anything for tap here, so we're going to use drill. And we'll basically, you know what? We don't even have to do this. I'm going to get out of this and say I don't want this operation. Say no. I can actually right click and say copy. Come down here and right click and say paste. And now we have the same exact operation twice, but now we'll go into the parameters and we will change this to suit. So it's still going to be a drill path operation, but the tool we're going to use is a 5/16 18. We'll put in the holder. We'll try to choke up on this. See if it'll take it, and it does. Okay. And our stock, we don't need to touch that at all. Cut parameters, we will. In this case, you want to choose tap. Okay. Now again, it's going to take a look at the information on the tool. It knows that it's a 5/16 18. We already gave it the feeds and speeds for this, so that's already committed to memory here in Mastercam. So we shouldn't need to really do much with that at all. There's really nothing else that we need to tell it other than the fact that it's a tapping operation. These items here don't need to be opened up. Linking parameters will. And the top of the stock, it remembers it as 0. And now this time we want to go minus 0.625. All right, absolute, absolute, absolute. And then we want to go to our coolant to make sure that's still on, and it is, and say OK. So if we go ahead and backplot this, we should see makes a one-shot deal here. You can see how far it goes down here. And looks good. All right, so that's acceptable. So now we're going to do one more thing in this session, and that is going to be drilling the 3 holes through. So we'll again bring this to top view. We will grab those 3 holes separately from everything else. So we'll right click here, Mill Tool Pass, Drill, and we're going to just pick those 3. So I'm going to start with this one over here. And then this one here. You see how it puts that green mark up there? And the last one here. Okay, it looks to me like I have too many points, so I'm going to get out of this. Do you wish to keep this operation? No. I'm going to go back and do this again because it has some confusion there. Drill. All right, now it's got the 3 that we need. It accepted that. You have to watch all this to make sure. You saw those lines coming here. You had to know right away there was some problems. So make sure you only have 3 captions. We have 3 that we captured, and it says NA because we're picking a point. And we're going to say OK on this. And then it's be time for us to fill in the letter F drill this time again. And your holder is remembered. Your cut parameters is going to be changed to drill, pec drill. So that's good there. Linking parameters, our depth, this is going to be 0 here. And retract is 1. The depth of this is going to be all the way through. So our piece is 1.25 inches thick. So I'm going to go 1.350 minus 1.35 to make sure it goes all the way through. And the last thing I need to check is my coolant, and that is still on, and I'm going to say OK. So now if I right click on this or bring it to isometric, we'll go ahead and just check this out to make sure this looks good. If you want to, you can do a dynamic rotation, and you can make sure that it comes all the way through by just left clicking your key and holding it there to see that it goes all the way through. Now if it doesn't, if it looks like it's not going all the way through, then you need to add some on that because it's not calculating the tip. So it looks to me like we need to go a little deeper. So we'll go ahead and go to isometric. We will go in here to our parameters, and let's go ahead and make the linking parameters at minus 1.5. That should take care of it, and say OK. And then if we want to, we can go ahead and click. It's already activated here. Just go up and click on verify, and we can just make sure that this goes all the way through, again, by rotating it dynamically. And now it's going all the way through, which is what we want. Okay. So we're good with that. We can get back to this. We can go to isometric, and we can hit save. Okay. Make sure you save your files often so that you don't lose it. So this is going to be it for session 2. We'll come back next time with session 3, where we'll finish up the holes through here, the bores, and our counter bores. Okay, so we'll talk to you later. Have a good day.